Alright, here are the video notes and some examples for 10.7. 10.7, we're really just going to be talking about using the standard equation of a circle. And we're going to get to that down here, what it exactly looks like. But what the standard equation, what we're able to do is if we just have, we can use the center of a circle and the radius. And we can use those to write an equation. And we're going to see down here when we're talking about the center is an x and y coordinate, but for the sake of the equation, we're going to talk about it using an h and a k. And the h, it's just the x value of the center where it's located, and the k is the y value of the center. And then of course we're just going to use r for radius, which we've already been doing. So here it is. If we let x and y represent any point on the circle, so any x and y that belongs on the circle, it has a center hk here, and then it has a radius r. And by the Pythagorean theorem, we can use this equation here. It's the quantity of x minus h squared plus y minus k squared equals r squared. And again, this is that's the x value for the center. That's the y value for center. And then this is our radius. And then these are just any x and y together located on the circle. So these are all these different x and y points. Alright, so for this first video we're going to work through examples 1 through 6. We're going to start with example 1. Now remember, all we need to be able to write a standard equation of a circle is we just need the center points, and remember we call that h and k, and then we need the radius. So let's get that information and then we're going to substitute it into that standard form equation. So the center, it looks to be actually what we call the origin here. So it's at 0, 0. So my h, which is the x value of the center, is 0, and my k, which is the y value for the center, is also 0. Now the radius I can see, I just go from the center. Remember, the radius is just any point, or any segment, sorry, that is from the center to any point on the circle. Well, I'm going to use the graph to be able to just clearly see what the radius is. So we got 1, 2, 3, 4. My radius is going to be 4. And now I want to take this information and I'm going to substitute everything in. I'm going to substitute a h in, I'm going to substitute a k in, and I'm going to substitute that radius r in. Okay, so my h is 0, so let's plug the 0 in for h. So I got that right here. My k is also 0, so let's plug that in here. And then my radius is 4, so I'm going to plug that in. Let's clean this up a little bit. Well, x minus 0, that's just x, and then I'm squaring it. Y minus 0, also just y, but then we're squaring. And then we have 4 to the power of 2, or 4 squaring, which is also just 16. So that is your equation for that circle. Let's go number 2 here. Remember, I need to find my center, my hk, and then I also want to find my radius. So the center here, what I'm going to do is I'm going to try to draw a diameter. Looks pretty good. And then I'm going to draw another diameter. And I'm going to be able to tell it looks like the radius, they're all the same from the center to any point. So that has to be my center. And that's located at 2, 2. So that's what I'm going to plug in for h and k. And then my radius then is just 4. So here's our equation again. X minus h squared plus y minus k squared. Set that equal to the radius squared. Let's substitute all this in. I get x minus 2 for h, y minus also 2 for k. My radius here is 4 to the power of 2. These can stay written like that, so I'm not going to change anything there. I'm just going to simplify 4 to the power of 2 to be 16. Alright, so 3 and 4 we're also just working with substitution. My h and my k here are 0 and 0 because that's the center. And then my radius in this case is going to be 1/3. So let's plug this all into my equation again. I'm going to get x minus 0 squared plus y minus 0 squared equals 1/3, and we're squaring that. Let's clean both sides up. We just have x to the power of 2 plus y to the power of 2, and if I take 1/3 to the power of 2, remember that power of 2 needs to be applied to both the numerator and the denominator, so this would be 1/9. Let's jump over to number 4. The center here is -3, -5, and my radius is 8. Let's plug this in. This is going to look a little different because I have negative values for the first time for my center. So I'm going to show you how that changes the equation. So I have x minus, but I'm going to use a parenthesis here. In this case I have -3, and then I'm squaring that. And then y minus, and I'm going to substitute in a -5 for where the k usually goes there. And then I'm doing 8 for r, taking that to the power of 2. Well, let's clean that up. Anytime I'm subtracting a negative, that is addition. So I have x plus 3 to the power of 2, and then y plus 5 to the power of 2 equals 64. So recognize that when you have addition in the quantity for x and y, those values are actually negative values for your circle, the center of the circle. And when they're the subtractions here, that's just, those are actually positive values. Alright, so we want to write a standard equation for 5 and 6, but now we don't have r for either one of these. What we have instead is a point, some x and y that exists, remember back to that, the outside of that circle. So at some point, if I have my circle over here, at some point on this circle is an x and y, and then we're given a center. Well, we can just use that x and y in our equation and solve for the radius in this case. So if I just write this out again, x minus h to the power of 2 plus y minus k to the power of 2 equals r to the power of 2. Let's substitute everything in. Well, my x and my y in this case are 4 and -3. So x is 4 minus h, well, remember my center, hk, is 0, 0. So I'm going to substitute 0 in there. And then plus my y now is -3, that's that y value we're going to use, minus a k, which is the 0 here, squared. We don't know the radius, we're going to solve for it. Well, 4 minus 0 is just 4, 4 to the power of 2, that's 16. -3 minus 0 is just -3, but -3 to the power of 2 is a +9. Then we have r squared. So now it looks like we have 25 equals r squared, and we can leave it just like that, because now we're going to use that r squared for our equation here in the end. So this equation now looks like x, we have 0, 0 for our h and k, so it's x minus 0 squared plus y minus 0 squared equals r squared, but we know it's 25. I don't have to, if these are subtracting 0, I don't have to really write that, so this is just x squared plus y squared equals 25. Alright, last example for this video, we're going to do that same thing. So I'm going to substitute, this is my h and my k are going to be 4, 5, and then my x and y that I'm going to use, just that point that's on the circle, is going to be 0, 8, and I'm going to solve for r. So now we have 0 minus 4 squared plus 0 minus 5 squared equals, oh, sorry, that's an 8. This is 8 minus 5 squared equals, we don't know the radius squared. So negative 4 to the power of 2, that's 16. 8 minus 5 is 3, but 3 to the power of 2 is 9. Again, we have a radius of 5, or an r squared of 25. You just square both sides to find r. Alright, so we'll substitute all these things in back into our equation. So we'd have x minus my h is 4 squared plus y minus my k is 5 squared, and this equals my radius squared, which is just 5 squared. So this is really x minus 4 squared plus y minus 5 squared equals 25.